For the second part of this discussion, we have abstract data types. So we have here that data abstraction is a powerful concept in computer science that allows programmers to treat code as objects. For example, car objects, chair objects, people objects, and etc. So the main idea here is that as programmers, we don't need to worry about how code is implemented all the time. We just need to know how we can use it and what it does. So for example, you might have used this function throughout the semester, list.sort. And all you needed to know is that it takes in a list and that it sorts it and returns, it doesn't return that list to you, but it sorts it. And now you can rely on the original list to be sorted. So unless you actually looked up the Python source code behind this function, you probably don't know how it's implemented, but you do know how to use it and how to make use out of it in your own functions. So that's an abstraction here, that we don't know the full details behind the code or how anything in this function is implemented, but we do know the inputs and the outputs and how to use the function itself. So data abstraction mimics how we think about the world. For example, if you ever drive a car, if you've ever driven a car, you probably didn't know or didn't have to know how the car was made or how the manufacturer made that type of car or the engine or the tires or anything like that. You just needed to know how to turn on the car and how to turn the wheel, press the gas, use the brakes, and so on and so forth. And the abstraction there is that there are the engineers who make the car that know all the details. And then there are the people who buy cars, the consumers that actually use it and drive it. Of course, people can know how cars are made, but for the average person, probably it's not likely that we know how the full story behind how cars are made. We just know how to use it. And so that's another example of abstraction, that we just need to know how to use something, and we don't need the full story to be able to get functionality out of it. So moving on to this idea of an abstract data type, so it's going to take advantage of this idea of abstraction, but to put it more concretely, an abstract data type consists of these two types of functions. And the way I like to think about ADTs is that it's really, so an ADT is, to me at least, a group of functions that represent an object. And this object could be anything, right? It could be a car, it could be a person, it could be a classroom, or anything like that. And then these groups of functions are typically divided into two types of functions. So you have usually one constructor function that makes the abstract data type, and then you have selectors that retrieve information from it. So the details about maybe the type of car, the year it was made, or something like that. Okay, and then as an example, we might have an ADT that represents a city. So the city could have a name, a latitude, and a longitude. And to create a city object, we could have a constructor that's called makeCity that takes in the name and latitude and longitude. So this is your constructor over here, makeCity. And then you could also have selectors that grab the information about the city. So you could have a getName selector, a getLat selector, and then getLong selector. All right, and then so these few functions all together represent the city object. And then as an example of how we would use the functions, you could make a city called Berkeley, and then grab the information from it using these selectors. So these are the selectors, and this is how you use the constructor. All right, and then to build on top of these functionalities, we could also have a function that computes the distance between any two cities. So it will take in city 1, city 2, and compute the latitude and longitude, well, not computed, but actually grab it using our selectors. So it can grab the latitude and longitude of the first city, latitude and longitude of the second city, and it's going to compute the coordinate distance between the two cities. So this is basically just your coordinate distance. So if you have like a point here, then it's going to compute the distance in the x direction, distance in the y direction, and then you can find the hypotenuse to actually get the distance between the 2 points. All right, so that's it for distance. And just to really, drive home the point of abstraction, we don't need to know how these functions are implemented in order to use them. So in this case, with the Berkeley example, all we need to make this happen is just to know how make city and get name and get lat and get lon take in any inputs, and we just need to know the name of the functions, and we can reasonably expect that they return a city, the name, the latitude, and longitude. And we don't need to know exactly what the code is behind them. And yes, we do need to know that someone else has already defined them for us, but we don't need to know how they defined it. Okay, so don't need to know how they're implemented, although someone else may have to define it for us. Okay. And later in this discussion, we're going to look into how to define constructors and selectors ourselves later. So we'll see the two different sides of the abstraction barrier, one where we're making the constructor and selectors, and then another where we're actually going to be using the constructor and selectors given by some like outside party. Okay, so and also note that the implementation and the use of an abstract data type are separate. So you should never assume anything about how the constructors and selectors for an ADT are implemented, because doing so is actually called a data abstraction violation, or you might hear it as like crossing the abstraction barrier or violating the abstraction barrier, because we want to be on one side of the abstraction barrier, and we don't ever want to cross it. We either want to be the implementer who does know the details, or we want to be the person using it and we don't assume anything about the details of how it's implemented. All right. Okay, just as an example of how you would make a constructor, here's an example of a constructor for a rational number. So it takes in n and d, and all it does, it's just going to return the list containing n and d. So here the abstract data type is represented by a list of the two inputs. Okay, and then we could call rational 3, 4, make one rational number and make another rational number with 5 and 6. And if you were to say frac 1 of 0, frac 2 of 0, notice here that when we use the brackets, we're assuming that frac 1 and frac 2 are lists. And this is really not good if we're not the implementers, because now we're assuming something about how it's implemented. Right, if we're on the other side of the abstraction barrier where we're just like given these constructors, the selectors, or something like that, then we really shouldn't be using like brackets to access a list, because we're not supposed to assume that it's a list. So doing this is really an abstraction violation. Because of the brackets. Okay, and because the brackets imply that we know it's a list. Alright, so if you were to fix this, ideally you should be given some kind of selector that's like called, get n, because in this case the first element of the list is n. So you could call get n as a function like taking frac 1 or something like that. And then this should give you n. So you should never directly access into the list because you're not supposed to know it's a list in this case. But again, if you're the other side of the abstraction barrier where you're implementing it, it's totally okay to do that, especially if you're making the selectors, because you're supposed to know that it's implemented in that way that you chose. So if you chose to implement it in a list, then it's totally okay to make your selectors access into the list. Yeah, okay. So for this first problem, we have a question that talks about the Hadley cycle. So the Hadley cycle describes the process of atmospheric circulation caused by rising air at the equator and falling air at about 30 degrees north or south. And the air loses water vapor to rain as it rises from the equator. Consequently, the falling cold air is dry, so that many regions around 30 degrees from the equator comprise of desert. So we want to write a function called near 30 that takes in city and diff and checks whether an input city is within diff degrees of 30 degrees north or 30 degrees south. If you didn't know, and it's totally okay, I totally had to look this up before, but latitude is the one out of latitude and longitude that deals with north and south. Because we saw north and south in the function description, this lets us know we're working with latitude. But you totally didn't have to know this, and we would never expect you to know like geographic details and everything like that. Okay, so what this question is really asking is whether or not a specific city and its coordinates lie close enough to 30 degrees north or 30 degrees south. And that close enough is defined by diff. So if diff is like really large, then we're okay if the city is pretty far away. And if it's like really small, then we want it to be pretty close. Okay, so when we talk about whether something is within diff degrees of 30 degrees north, what we can do is something like take the city's lat. So let's say the city's latitude is, 35. What we can do is do 35 minus 30, which is 5, and then check if 5 is less than or equal to diff. And if it is, then we know it's within diff, and we can return true. Now, if diff is something like 4 or 3, then we know it's like past the threshold, so we wanted to return false. So our code is going to do some kind of math like this. Okay, so first things first, we want to get the latitude of the city. So I'm going to say city latitude, get lat city. And now I want to do that math of checking whether it's in the threshold or not. So we have to do absolute value because we don't know which one is bigger, but we just care about the difference. So the absolute difference, not the actual difference. City latitude minus 30 is less than or equal to diff, or abs of city latitude plus 30 is less than or equal to diff. Okay, and that should give us the answer for near 30. So moving on to the next video, we'll be talking about the next question that deals with the discussion ADT.